Major support for Do the Math has been provided by Chevron, California Resources Corporation, Edison International, Center for Neural Skills, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, Tuolumne County Superintendent of Schools, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Scott.
And I'm Nadesh. For math homework help, call in Bakersfield 636-4357. Everywhere else, 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net. And on social media.
Well, Nadesh, thank you for taking care of that, because I know Scott and myself have a little bit of difficulty getting through that whole thing, so you did a nice job on that.
Yeah.
So where do you go to school?
Stockdale Elementary.
You go to Stockdale Elementary. What grade are you in?
5th.
How is 5th grade?
Good.
So it's the beginning of the school year, and you said that 5th grade is good. What is so good about 5th grade?
I actually don't know.
You actually don't know, but you like it and it's good.
Yeah.
All right. Well, I do know that you like solving puzzles.
Yeah.
So we're going to do a little bit of that today. You ready for that?
Yeah.
All right. And is there anything that you would make better about 5th grade to make it great instead of just good?
Nothing, maybe?
What was
Nothing.
that? Everything's fine right now?
Yeah.
So instead of it being good, it actually is great.
Yeah.
Would you say it's fabulous?
Yeah.
Okay, well, we'll just leave it at that. And it might be even better as the year goes on, right? Okay, so we have a lot of things that you're going to do today, but the first thing I need you to do is help me with our social media problem of the day. Because you said that we're on social media, right?
Yeah.
So we send out a problem every day, and a lot of people answer it, and we get a lot of different answers sometimes. So I need you to officially solve the problem. You ready?
Yeah.
All right, let's take a look at it together. So it says problem of the day, and it says find the perimeter. Now, do you know what perimeter even means?
Perimeter means like the border of a shape.
Right, the border of the shape, right? The distance around it, okay? So we're going to find the distance around it, the border. So what numbers do you think we need to pay attention to up there?
20 and 12.
Right, 20 and 12. And do you know what that FT means?
Feet.
Feet. So we have 20 feet and 12 feet. And what is that shape up there?
It's a rectangle.
It's a rectangle. How do you know it's a rectangle?
Because one pair of sides are smaller than the other, like shorter than the other.
Okay, that's a good way of summarizing it. And another important thing would be that they have 90-degree angles,
Yeah.
right? You know what different angles are, right? All right, so how do you want to go about solving this problem? Because we know we have to pay attention to the 20 and 12, we have a rectangle, we need to find the perimeter. So what do you want to do first?
So first I would add 20 plus 12.
So what do you want to add first?
So I would add 20 plus 12.
Okay, and that's 32, correct?
Yes.
All right.
Then I multiply by that by 2.
Why 2? I don't even see a 2 up there.
Because we have two sides on the rectangle. So we have two 12s and two 20s.
But I only see one 12 and one 20.
If you just take the other side of each number. So you see the on the line under above 20,
Right.
You see another line the same length as that above the line.
So the line on top is the same length as the line on the bottom.
Yeah.
So even though it doesn't say 20, we can infer that it's 20. All right, so I'm with you so far. And the same thing with the left and right sides?
Yeah.
Okay. So you're going to take 20 and 12 and add them up, and you get 32, and you're going to times it by 2 because you're saying there's 2 of the same measurements, but we just don't see them written down.
Yeah.
Okay, and what would you get?
64.
64. Now I see 2 64s up there, so we're going to stop for a minute. Instead of taking 32 and timesing it by 2, is there another way to solve that problem instead of multiplying?
Yes, you
How?
just add 32 plus 32.
Okay, we could do 32 plus 32. And that's another good way of doing it. But is there another way to do it instead of adding 32 and 32?
You could add 20 plus 20 and then 12 plus 12 and add those two.
That's what I was looking for right there, brother. You got me now, right? All right. Do you think we're going to get the same answer every single time?
Yeah.
What do you mean, yeah? Are we or
yes.
aren't we?
Oh, we are.
We are. Okay, that's what I want. A little confidence right there. Now, you said that the answer was 64, but I see two 64s up there. What's the difference between them?
64, 2 is like you multiply like 32 times 2, and then 64 is like adding. Probably.
Okay, so what do you mean 64 2? The one with the
It's
little
like-
tiny exponent up there?
Yeah.
Okay. Do you know what that's called? It's called an exponent, right?
Yeah.
But that would be called 64 feet
Times 64 feet.
squared,
Oh, yes.
right? When you see a 2 up there, it means you're squaring something, right?
Yeah.
So it'd be 64 feet squared. Now, a lot of people on social media said that the answer was A, 240 feet squared. Why do you think they would say that?
Because they did 20 times 12.
Right,
so
they
it
did.
equals 240.
Right, they did 20 times 12, and if they did that, what were they finding instead of the perimeter?
The area.
The area, right? You are all sorts of on top of this problem today, dude. All right, so we have 64 and 64 feet squared, but you don't like the 64 feet squared. You like the 64 feet instead?
Yeah.
So your answer is going to be C?
Yes.
Now, are you saying that because I think yesterday's answer was C? Did you watch yesterday's show?
No.
All right, well, all right. I was going to say, we're just going to roll with C for the answers. But anyway, you think it's C.
Yes.
All right, let's take a look and see if indeed you are correct. There you go, brother. First problem all done. See how easy that was?
Yeah.
Nicely done. 636-4357 is that phone number. We do have phone tutors available Tuesdays and Wednesdays between 3:30 and 5:30. Time now for today's Math in the News. And today's Math in the News, we are delighted to have not one, but two people in to visit with me today. We have Hilda, who is with the Kern County Superintendent of Schools office, and we have Yolanda, who is with the Knowledge Shop. So I know that you are a tutor and have been for many years with the Kern County Superintendent of Schools to do the math TV program. But you have a bigger role with the county office now, and what is that?
So I am a content coordinator for mathematics. So we service schools in our county, but we also do a lot of workshops and different community activities.
And I want to let you guys know something, because it wasn't you that was out there, but Mary Lou had visited a school, or let you all visit schools and stuff. And I'd met a teacher today, and they said, hey, does that person work at Do the Math? And I said, yes, they do. And they said that they came out to their school last year and just thoroughly enjoyed the presentation and the way you guys presented whatever it was you were doing. But they really enjoyed the whole thing and the way everything was handled. So kudos to you guys and everybody up there that's doing that.
Thank you. Yes, yes. We have a team of 9 now. So
All right, good.
9 people
Ever
serving
expanding, can't have
mathematics.
too many math people.
Always,
All right,
always.
Yolanda, you're a math person also, right?
Well, I'm the family expert. I go to the math experts for the
Okay.
math piece.
So tell us a little bit about the Knowledge Shop.
So the Knowledge Shop is a non-profit that's been run between me and my husband for the last 10 years.
Okay.
We're based in South Central Los Angeles, but we've come all the way to Bakersfield to bring our vision and talent and nuance to partner with Kern County Superintendent of Schools to bring family math to your whole community.
And Family Math Summit is going on right now, correct?
So we launched it last Saturday. 136 families showed up for our brilliant launch from 8 to 2 at Cal State Bakersfield, and it was fantastic. But now the work begins this Saturday.
Now, I think we have some footage right here. So tell us what's going on here.
So that's the children and the families that all showed up and registered. Last week when I was walking through the Dollar Tree in Bakersfield, and a kid said, "Are you the math lady?" So obviously Do the Math is watched by a lot of your community, because I was like, okay, where do you want me to sign? I'm the new Oprah in town. So the parents are learning with their children here at the launch at Count Us In. So we hope that you'll all come out. It's from TK to 8th grade, and we have 30 places every Saturday per child and family.
All right, so every Saturday this is going on.
Every Saturday from now until January the 31st.
So that's like a bonus month you're giving everybody, right? Because I
Yeah.
thought this was going on for the rest of this year.
No, we're going right into the new year with math, more math, and math into the max.
And you have been doing this for a number of years now.
10 years.
And you're just bringing it to Kern County. So what have you seen as far as growth over those years in how people are accepting it and what they're doing with what they're getting from your summits?
So what happens is our families then learn how to work with their children at home. We let teachers do the great work in the classroom, and we teach our families and our students how to do the work at home and help their children. We've seen children become engineers, astronauts, astrophysicists, and scientists. And right here in Kern County, you've got all those employers looking for that talent. So if we get it right in schools, they're going to be able to get jobs later on in the next 10 years.
Yeah, there you go. And did Kern County kind of approach Yolanda and those guys, or did Yolanda come up and ask you guys about this?
Well, actually, Yolanda is in a lot of spaces in the state, throughout the state.
Okay.
So she's very well known with a lot of different organizations, and so I think we've crossed paths many times. And Dr. Cole Sampson, our assistant soup in curriculum, met with Yo and came up with a plan, and so we're here. This
Good.
is where
Well,
we
you
are.
know what? I'm glad that you're here, and it's also
Thank you.
exciting to have new things as far as mathematics go, and different opportunities for families to get together to see how they together can work with mathematics and show, because there are a lot of adults, I know there are times when they go, oh, you know, I wasn't too good at math, and if my kid isn't good at math, it's just one of those things, I wasn't, so they're not.
Right.
Which is a fallacy,
Totally.
right? Because every single person can do math.
Yes. Math is everywhere, right?
Right.
Look
I mean,
around the
it's not-
studio, it's everywhere.
That's why we have people in all the time. We talk about all the mathematics behind
Yes.
everything.
Yes.
But you don't often hear people go, well, you know, I'm not very good at reading.
Right.
They don't readily let that
Right.
out.
Exactly.
But people don't have a problem going, I'm not good at math.
Right.
Right.
And that's just a mindset that people have. And I think that what you're doing is helping to erase that.
Correct, and shift the game. We got to equalize math alongside reading. You got to be able to read and do the math together, and that's what we want our families to learn in the next 6 months, from TK through to 8th grade.
Okay.
And thank you, Kern, for providing the food, the childcare, and the support materials
I was
the
going to
parents
say, to
couldn't
make
even
it
go home.
easier for families to go, you've got
Right.
childcare. I didn't know you had food there. You got some nice food going
Yeah,
on?
we give
You
them
go away
breakfast
this
and
way. I'll be
lunch.
going up,
And
check
you
that
should
out, do a
mention
little bit
family
of math.
circles.
And then we have 2 final extras, motivational math session and a family circle. We're taking you to Mexico to learn how the Aztecs and the Mayans introduced math, and then I'm bringing you to Trinidad, which is where my family's from.
Oh, now
and
hold
African,
on. Now.
I
You
know,
see,
I
you're doing
know,
some
I
traveling.
know.
Let me get my bag together there. Sister, you and I, you go like this. Hey, we're bringing old man Mike along with us.
I'd love to.
Now, I know there's a QR code on the screen right there, and we want to put that up for a moment or so that families can go ahead and take a photo of that, and they can take a look at that and put that on their phone, and they can register
Correct.
for some of these that are going on.
Yes, they need to register because, as we said, this is a very large county with 46 school districts, and we only have 30 places per Saturday, per grade level, per family. So don't miss out. Sign up as soon as we finish with this shot on TV.
Well, Yolanda, we certainly do appreciate you taking some time to come visit us here
No
at Do the Math.
problem.
Lovely to meet you.
Lovely. Thank you so much.
Hopefully we see you in Kern again. It's not, you know, like a pit stop and it's almost one and done, but you've done it for 10 years.
Yes.
You and I will meet again for 10
For
more
sure.
years doing this?
For sure. Every week I'm in Kern. So you're going to see me every week for the next 6 months.
Well, I expect to see you around, Hilda. Lovely to see you again as well.
Yes, always.
All right. Once again, the Family Summit going on. It's going on through the end of January. We'll be back with more right after this. All right, our next mathematician is an Italian lady, Maria Anayazi. She was fluent in 7 languages while only a child, and she wrote an essay about the need for higher education for women, and it was published when she was 9. When you're in 4th, 5th grade, you're already fluent in 7 languages, and you write a book talking about the need for higher education, and the book is published when you're 9 years old. Quite an accomplishment for Maria. She wrote math books to show how math fits together and to show good problem-solving techniques, which is exactly something all of us do every single day. You have to have good problem-solving techniques. So, Maria taught her younger brothers geometry and wrote a textbook to help people understand math better. The figures below are isoperimetric. That simply means they all have the same perimeter. So we're going to see which one has the largest area. Let's go ahead and start with an easy one down here, the rectangle. 10 times 26 is how you find the area of a rectangle. So if we do that, we have an area of 260. All right, well, we'll start there. A square, 18 times 18. Well, if you take 18 times 18, 18 squared, And we'll just use our calculator to make sure we've got 324. 324 is definitely bigger than 260, and we know that when we get to a square, we have probably the largest area that you can have using straight edges. Just to make sure, let's take a look at this rectangle, 12 times 24. So we'll go 12 times 24, and this one we get 288. So it's a little bit larger than this rectangle. The reason why it's larger is because the numbers are closer together. Here, the difference is 16. Here, the difference is 12. The closer you get and the smaller the difference, the greater the area you will have. So, we know that when we're taking triangles, we're going to take 1/2 the base times height. So we're going to take the numbers that are there, we're going to cut them in half. It's not going to be anywhere near these ones. The odd thing here, though, is this circle. To find the area of a circle, we're going to go pi. Then what we have to do is we have to take the radius and we have to square it. So we can see that the radius is 11.46. So let's take 11.46 and we're going to square that. And we can see that we have 131.33. We'll just leave it at that. But then we also have to remember we have to multiply this by pi, which is 3.14. So we'll take that times 3.14. And now we come up with a number that is approximately equal to 412. Obviously, a bit bigger than the 324, but if you need straight edges, the square is the way to go. If you want to optimize the total 72 feet of fencing you've got, put it in a circle. That's what Maria Anayazi helped us with, our mathematician of the day.
Did you know that Welsh mathematician Robert Ricord introduced the equal sign? He explained his choice of the two parallel lines to represent equality, since nothing can be more equal than two parallel lines. Now you know.
And in studio with us, we have Nadish, a 5th grade student at Stockdale Elementary. Everything going well so far?
Yeah.
Good. Glad to hear that. So I know that you like solving puzzles, and this is kind of a puzzle that I'm going to ask you to solve right now, okay? And this is a little bit more advanced than what you would do in 5th grade, but I know you're a little bit more advanced than the average 5th grader, aren't you?
Yeah.
All right, yeah, that's the way to be confident about that, brother. All right, so what I need you and Scott to do is head on over to the board. And first of all, Nadish, I would like you to tell me if you know the mathematical term for those different shapes.
This is a pentagon.
How do you know it's a pentagon?
Because it has 5 sides.
Okay,
And this is a hexagon because it has 6 sides.
hexagon.
And this is an octagon because it has 8 sides.
Perfect. All right. So why don't you grab one of the markers there, Nadish, and let's start with the pentagon. So you get right over there next to Scott a little bit, and I want you to draw a line from the top vertice down either to the left or to the right along that edge.
Well done.
All right. Do you know what that line is now called?
A line.
It is a line, but it is called a diagonal also.
Yeah.
Okay? So what I'd like you to do is, starting up at that top, can you draw any other diagonals from that spot?
From here?
Yep.
Okay.
All right. Is it possible from that starting point to draw any other diagonals?
To any other tip?
No, starting
From
at
that top spot, can you draw any others that you haven't done already? Well, you have to go to another vertice. You have to go to another corner, right?
I like how you went to the side there. That's a good idea. We'll take that one off there real quick. Are there any other corners you can draw one from here to that other corner? Seems like you go right there. What would you call that part, though? Instead of a diagonal, what really is that?
It's like the perimeter.
That's just a side, right? Yeah.
That's
So I mean,
just-
really,
you can't
that's
use-
about all you
that's
can do
not
is
a
what you did
diagonal.
before. Yeah.
So are there any more from that starting point?
No.
All right, so go to the right. That point, can you do any diagonals from there?
Yes.
Good. Any more? Hey, looking good. All right.
All right, so I don't think you can do any more from there. What about the bottom right? All right, so taking a look now, are there any other diagonals do you think you could make from any of the vertices?
No.
No. Do you remember how many lines you made? Because I was counting them for you, but
Yes.
how many did you make?
5.
5. So underneath it at the very bottom, put 5. So that had 5 diagonals, all right? Do the same thing with the pentagon. And you and Scott can talk about where you're putting the diagonals if you've got the right number of them.
Now, Nadish, just real quick, that's a great start. How did you choose this point to start with? Why did you choose that one?
Because I saw that I could make a few diagonal
There you go.
points.
Could you have chosen a different point?
Yeah.
Yeah, you could have chosen anything else, right? You just happen to start at the top left. That's fine. Where do you want to go from here?
Here.
Okay. And you can go up there. Good. Straight across. Is there another one? Okay, so before we get too confusing, how many have you drawn so far?
6.
You've drawn 6 so far. Do you think we're done? Because this one had 5 sides and had 5 diagonals. Do you think we're finished?
No.
Oh, we're not finished. It's not quite the same pattern, right? Okay, let's draw some more diagonals and we'll keep counting them. So that one is how many?
7.
7, yeah. And you got another one there, 8. Any more?
From here.
Okay. Oh, and that one's 9.
9.
Yeah, that's kind of interesting. So for some reason, if you had 5 sides, you can draw 5 diagonals, but if you have 6 sides, you can draw more than that. How many?
9.
Okay, put a 9 on the bottom there.
All right, so what I want you to do is I want you to think, is there a way to figure it out without drawing the diagonals to tell how many diagonals are in the octagon? So you and Scott will help. You guys can write stuff up above where there's some open space. Is there a way that you can figure out kind of like a formula or something, a way to figure out how many diagonals there will be based on what you've done already so that you don't have to actually draw them because it might be a lot as we get into more sides?
Right, yeah. If we had a dodecagon or something like that, there'd be a lot of diagonals, right? So what do you think? What would be the pattern here? There were 5 sides and 5 diagonals. Boy, it'd be nice if it was like that every time, right? 5 and 5, there'd be not much to do. But then we went to this one, so this was 5 went to 5, and this one was 6 went to 9. What in the world? Any idea at all about a pattern that would fit both of those sets of numbers?
So I could infer that 8 goes to. Now we need to find the number.
We need to find the number, that's right, without drawing them. So let's see if we can find some kind of mathematical pattern where 5 turns into 5 and 6 turns into 9. What's one way that 5 can turn into 5? Plus what?
Plus
Plus
0.
0. 6 plus 0, is that 9?
Plus
That doesn't work.
No.
Okay, what about times? 5 times what is 5?
1.
Right. 6 times 1,
No.
that's not 9.
Right, this is going to be more difficult, so I'm going to
It's going to be quite a bit more, right?
All right. So Scott, way up above on the top, if you could just write n, and that Nadish is going to stand for the number of sides.
Okay.
So now, Scott, underneath that, put n, and then open parentheses, n minus 3, close it, put a fraction bar underneath it all,
Underneath everything?
that, right, and put 2.
Okay. Wow.
Now, Nadish, the reason we're going to divide by 2 is because if you go one way and if you follow that diagonal back, it's the same thing, isn't it? So that's why we're going to cut it in half by 2.
Okay.
So having that right there, see if you can figure out how many diagonals will be in the octagon.
Wow. So you want to make sure that this works with this one first? Okay, so we'll do that real quick. Ready? N is 5, right? That's the number of sides. So we got 5 times 5 minus 3 over 2, right? Let's see what happens here. What's 5 minus 3?
2.
2, that's a 2. And what's 5 times 2?
10.
10. And 10 divided by 2?
5.
It's 5. So that works, right? So you can see that this is a little more complicated than we probably would have gotten with what we were doing before, but it looks like it works. So let's see if we can use this one
For the
all the way
six.
over here for how many?
8.
8. Okay. So let's see if we can do that one real quick. What's going to happen here? So what goes first? What goes in place of the n?
N.
Yeah, but what number is it now?
8.
It's 8, right? And then we do parentheses. What did I write next?
8.
8
Minus 3.
minus 3, good. And then all over what?
2.
2. All right, tell me what to write next.
Then you do 8 I mean,
We got the 8 on the outside, right? And we're going to multiply it times this part in the middle because
yeah.
we're
So
going
you have to do first. You have to do 8 minus 3.
Yeah, what's that?
5.
Good.
And
We're
then
going to put a 2 down there again, right?
and then you have to divide that by 4.
There you go. So
2.
what's 8 divided by 5? Or sorry, 8 times 5.
40.
Yep, 40. And 40 divided by 2?
20.
20.
That's the reason I didn't want you drawing 20 diagonals, because it would be difficult to do that, keep them in order, and count them all along. So Nadish, by doing that problem and figuring out how that works right there with that n times n minus 3 and then cutting it in half, you are all ready to start working in algebra at a higher level. And you know what else you're ready for?
What?
You are now ready to go to the Kern County Fair, so congratulations on that. For doing that great problem, you've got yourself a couple of tickets and a parking pass to the Kern County Fair. Congratulations. Hopefully you have an opportunity to go to the fair and check that stuff out. We'll be back with more right after this.
Hello everybody, my name is Ross Salcido. I'm with the Southwest Carpenters Training Fund apprenticeship program out here in Bakersfield, California. What I like to do is I like to introduce you guys to reading a tape measure. So what I have is here a dissect of 1 inch. In 1 foot we have 12 inches. Each inch consists of 16/16ths of an inch. So out there in the field when you're measuring, you want to measure half an inch, you go 8/16ths, which 8 times 2 is 16, 16/16. So as we go through the tape measure readout, we go with the first tick, which is 1/16, second tick, 1/8, 3/16, 1/4, 5/16, 3/8, which is 6/16, half, which is 8/16. Then we have the 9/16, 5/8, which is the 10/16, 11, 3/4, which is 12/16. Then we have 13/16, 7/8, which is 14/16, and finally we get 15/16, and to end up with 16/16. So how do we apply this on the field? So when we hook up a tape measure, we have the connector at the end, which basically what it has a little play on it, but this tape measure, what it does, it has a pull and a butt to it. So when you butt the tape measure to it, it creates that slag, the difference, which is that 16th of an inch at the point. When you tug on it, it's going to expand that 16th, so that's going to cover the actual dimension from the point of projection to the end. Okay, understanding that you have 12 inches in a foot, and you can dissect it to the 16th, and that's what we have here on the tape measure.
Always an assortment of tools in mathematics, and thank you right there to all of those guys that help us out. They're just fabulous guys. I mean, we've all worked with them, and it's just fun to go check that stuff out. Hey, we do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. Phone numbers are at the bottom of your screen periodically throughout the program. In studio with us, a 5th grade student from Stockdale Elementary, Nadish, and that was some pretty heavy work you just did right there, right? All right, good. Well, you can share that knowledge with some other kids, and the more you share that knowledge, the more you're going to retain it. And it'll be easier for you to understand. And did you know that your brain just grew?
Yes.
You did? Could you feel it?
No.
No, all right. I was going to say, how do you know that already? But every time you work on something that you haven't done before, your brain actually does grow, right? So the more you learn, the bigger your brain gets and the more knowledge you have. Just like that Knowledge Summit that we were talking to Yolanda about, right?
Yeah.
Maybe you go to the Knowledge Summit sometime and check it out, right?
Yeah.
Who knows? You ready for another problem, a little puzzle to
Yes.
do? All right, over to the board, young man. All right, Scott, I'm going to have you start on the far left. We're going to write down a series of numbers.
Okay.
So we're going to start with 1, comma, -1, -3. All right, Nadish, I want you to find the sum of the first 10 terms of that sequence.
Wow.
You and Scott discuss what you think you need to do. Let me know when you're ready.
Is that a pattern?
That's a great idea. That's what we always want to look for, right? In math in general, but specifically in algebra, we're always looking for patterns. What is the pattern here? How do you go from 1 to -1?
-2.
-2, okay. What about from -1 to -3?
-2.
-2, there you go. So what do you think might happen next?
-5.
minus 2 here.
Oh, yeah.
But that part is going to be
-5.
-5. I got you there. Okay, so we want to find the sum. What does the word sum mean, by the way?
Add, addition.
Yep. We want to add those together. The sum of 10 terms, right? I think that's what I heard correctly.
Yeah. So this would be 1, 2, 3, 4 terms.
That's 4 of them. Should we write them all out?
No.
I mean, that's one way to do it, right? I mean, you certainly would have the exact numbers we need to add up together. Here's one question maybe I can ask you. If we have, how many more are we going to have, by the way? 2, 3, 4, how many more?
2.
Yeah, 2 more after that, huh? 5, 6. We're going to have 6 right there that we don't know and 4 of them right there. When we add all those numbers together, are we going to end up with a positive number or a negative number?
Negative.
How do you know that?
So if you add all the negative numbers, it's -9.
It's like a bigger negative, huh? Yeah. So right here we have a -9 and then we have a +1, so that'd be -8, but it's just going to go down from there, right? So we know at least the sum is going to have a negative in front of it. It's going to be a negative number. How big do you think that number is going to be?
-7, -9, -11.
Oh, he's going quick.
-13,
-7,
-15,
-9, -11, -13,
-15,
-15,
-17.
and -17. Well, that's a pretty bad 15, but we'll get there eventually anyway. So is there a way to add these up together where we don't have to just make a big, long stack of numbers and add them together? Is there a pattern you can find to adding them together?
Yeah.
Yeah, that's the right answer. I like it. Yeah, there is a pattern. What is that pattern? Which things can we put together to make things a little bit easier to add together? For instance, what is -9 plus -11?
-20.
-20. What is, which ones do you want to add now?
These two.
Oh, I like it. What's the add?
-20.
Uh-huh. What's next? Oh, it's almost like you're finding a pattern within the pattern. Look at that.
And then
What about
this-
-3 and all the way over here?
Yeah, that's
-20. Okay, and what's left?
And -1.
And then tell me about these two numbers here. What's 1 plus -1?
0.
They just cancel out, right?
Yeah,
So
0.
now, instead of adding all these numbers together, what can you add up together instead?
-80.
Wow. That was a lot faster than I thought it would go, right? And because you found the pattern to find the next term, and you also found the pattern about how to find the sum quickly. Oh, you like green a little bit better there too, huh?
Yeah.
What do you think about that one? That's a pretty quick way to do that. Oh, he's disappointed because we're going a little faster than
No,
he thought.
pretty slick, because I'm glad that the first thing that came to your mind was, let's find a pattern.
Yes.
Because as Scott and you said, there is a pattern in all mathematics, you just need to find it. Because there are a lot of students that will go 1, -1, and figure out that those cancel out. But then a lot of students will go -1 and -3 is -4. -4 and -5 is -9. -9 is, and they keep going like that, right? But the key is to find compatible numbers. Compatible numbers are where you take them and make it easier. That's when you guys took the -9 and 11, made 20, and then you saw just keep going 1 on each end, and it keeps doing that, so you get 4 pairs of -20. So there are always a lot of different ways to do math problems. The key is, can you find an easier way or a shorter way, a way that you understand, or find a pattern? So that's beautiful work right there in the dish. We'll be back with more right after this.
That's a great question. In fact, 2,000 or 3,000 years ago, ancient people on this planet that did great things figured out that the Earth was round. It was a sphere. This was a magical revelation for the Greeks and the Egyptians, who were able to see from the motions of the stars and the way the sun moved. They saw the way the sun's shadow worked in different places. And they figured, well, that's only possible if the Earth is round. And they took that information and it extended into the time of the great mariners that explored our Earth by ships. They made the first orbit of Earth by sea, and they knew the Earth was round, allowing them to go across one ocean and come back home the other way. If the Earth were flat, they would have sailed off the end. And so we knew that. But then, at the dawn of the space age, in the late 50s and 60s, we were able to see for ourselves that our beautiful home is a gorgeous round object known as a sphere. And that was really special. It put ourselves into context of our solar system and our universe. We have a big round sun and a beautiful round Earth and a round Mars. And today, we use the roundness of Earth, the spherical Earth, to use methods in space geodesy to figure out where we are, where we're going. I haven't been lost in years. That's pretty good. What's happening to the Earth? what's happening to our oceans as we take the pulse of our planet, and consider other worlds beyond as we explore those. So as we get ready to go back to the moon with women and men and explore other worlds, the roundness of our solar system and our universe is a special thing, and we should embrace that as we understand why our planet isn't flat.
Now, when that was on, you sparked up a little bit, right? You just said you wanted to be what?
A NASA engineer.
Why is that?
Because I like building stuff.
All right. Well, that's one thing because you like Legos too, right?
Yeah.
Building stuff like that. So who knows? You could be a NASA engineer someday. And you know what? I think actually in 5th grade, I think with one of the programs that you're in, you actually are going to get an opportunity to go to NASA, the JPL, the Jet Propulsion Laboratory. So that's going to be pretty cool, dude. That's right up your alley, huh?
Yeah.
All right. You know what else is right up your alley? Doing puzzles and struggling with things, right? So we've partnered with Struggly this year, and it's a program where you work on different types of math problems, but there are never any directions to the math problems, and I'm not going to tell you anything, okay? The only thing I'm going to tell you is good luck and get going with it, all right? So this is called roly-poly-oly. Okay, so I want, it's not roly-poly-oly, is it? It's, yeah, it's roly-per-oly. Roly-poly-oly, that's a character on something, wasn't it? Or something? All right, so anyway, we'll move on from that. All right, you ready? All right, you and Scott over to the board. All right, so you two are going to start, you don't need the pens, you're just going to use your fingers. So you two are going to start working on this problem, and go ahead and talk about it amongst yourselves, see if you can figure it out, because there are no directions.
There are no directions.
perimeter?
All right.
This is why it's called Struggly.
So perimeter, yeah, you at least see that part. So what do you think? We should draw some shapes or something and find the perimeter?
So we have to find the perimeter of this.
I don't know. Let's see. Press that button in the middle. What happens there? Oh, there you go. You can put a number in there. What happens if you press that button in the middle, though? Oh, I got you. That's where we type it in, right? There we go. Okay. So what do you think? It says perimeter, and it says each one of these things here is 1 centimeter. Where'd that come from? Oh man, rock on. So that's kind of a neat way to do it. They actually took all 4 sides of this one and spread them out into kind of like a net, right? And then be able to see that it's 12 if you had a straight line. Level 2? Okay, what are we gonna do on this one? Now tell me what you're thinking. I know you can find the answer.
Yeah.
I know you can find it. He's like, yeah, of course I can.
This is, so one side of the cube equals, I wish we had a pen.
That's all right. So each little line is 1.
So 1.
So what are you gonna add up here?
So there's 3 lines, so
Yeah.
that equals 3.
3,
And then there's 2, so there's 2.
2.
And then you just add both of them up, 5,
Okay.
and then times that 2, so it's
It's almost like they planted this one as the social media problem of the day.
Yep.
Man, that works
Kind of
pretty
all
well.
ties together, doesn't it, Scott?
Roly-poly social media or something. I don't know.
Roly-per-oly.
Oh, yeah, there you go. Sounds good to me. Level 3, Now, the last one was 10. Hold on, don't count. Ready? Do you think this one's going to be bigger than 10 or smaller than 10? Because it's long and skinny, but it's not very thick.
Bigger.
Bigger? Okay, let's see what happens. Count them up.
9. 9, and then 1.
1, 2, 3, 4, 5, 6, 7, 8, 9. Man. Did that work? Uh-oh.
Uh-oh.
See what
so
happened
this
here. So you
challenge-
counted 1, 2, 3, 4, 5, 6, 7, 8, 9. You definitely counted 9. That was great. And there's another 9 on the bottom. What about the ends? Ah, there we go. So what are we going to put here instead?
20.
20. Wow, that's a really big number.
Yeah.
Hooray for an
that's
erase
like
bar. Okay, let's see what happens. Oh, see, when they flopped it, they got that 1 there. Now you can see the big 20 there, right?
that. Yep.
Nice job.
Keep going. I want to see if you can get up to level 5, the grade you're in.
Oh man, what's going to happen now? We got to add them all up together. Now, is there a fast way to do it? A pattern, like you've been finding the patterns today? Or are you just going to keep on adding the numbers?
I'll push those there.
Okay.
No way.
That'd be nice if you could kind of move them around, huh? Oh, you can move it? No way. Whoa! Man, oh man. That went kind of crazy, huh?
Well, maybe just go about counting them the way you were.
That's a lot of them. So it had some little pieces and some pieces for 2 boxes, right? And then some big old long pieces.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.
You think it's 20? Did we get all the sides?
Yeah.
We're gonna find out real quick, huh? Hey, look at that. So if you just keep on making the thing go over and over, hence the roly-poly without the poly.
All right, now we're on level 5.
Okay. Oh, here he goes. He goes,
Oh,
please
look
just,
at it. Now he's like, oh,
please
let's
just
use
do
this
this for
play
me.
button. But you can't see them all.
But what happened over there? We missed it. Where did it go?
Can't go
That's
back.
5.
Oh, there we go.
That's 10.
Okay.
That's 15.
Okay, and then now you maybe count the rest of them.
That's 16.
Oh, that's 20 right there, though, if you go there, huh? It's kind of an interesting way to
That's
do it.
16. That's 19. That's 21.
Okay.
That's 24. That's 26.
26. It's a challenge. It says it's a
Okay,
challenge.
you're on level 5, so
And
you
so,
got one more shot. Take a
Definitely
look if you
found
can get
these
this.
ones that were on the outside. See when you
Okay.
flip them all the way around? That was 26. I like that part. That's a good way to look at it.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 so
Good.
far.
But we have the 26, so hold on real quick. You got this part, and you got that part, that part, that part, and that part. Which parts are we missing if you look at the picture? Which parts would never land on the ground if this thing was rolling? What parts would not touch the ground? Like look in there. There's a
part?
piece there and there's a piece there, right? So maybe if we add those pieces to your 26, we'll get the right answer. How long is this side here?
No, it added because the 3 and the 3.
Okay,
That part and that part.
all right,
Okay, so this is 17.
okay.
Oops.
Oh, go back. There we go. Got to go back to that one.
And then just go 1, 2, 3.
Oh man, it's spun around there and everything.
Okay, and then I just do 5 for this side. So that's now 22.
Okay,
And then 5 for another one. No.
so maybe it's 27.
I understand. It's 28.
Hey,
There
that
you
worked
go,
out pretty
nicely
well.
done. So come on over here real
I
quick, you
accidentally
guys.
did that.
So that was nicely done. So that's struggling. So that's pretty cool. So you guys were able to figure it out. There were no directions, right? That's why
Yeah.
it's called struggling. And guess what just happened while you were doing that?
I was learning.
You were learning. And what happened while you were learning?
My brain grew.
Your brain grew. There you go. Your brain's going to grow so big today, I can't even believe it. You got some awesome growth going on today. You dig that game?
Yeah.
That's fun stuff, isn't it?
Yeah.
All right. You know what? We'll be back with more fun stuff right after this.
Plasmas are really the first state of matter, right? After the Big Bang happened, everything was in the plasma state. It took hundreds of thousands of years for things to cool down, for the plasma to turn back into a gas. So they're 13.8 billion years old. But if you think about it in terms of when they've been being studied and turned into something practical, that's fairly recent. Plasma is an ionized gas. Now, if you were to take gas and add a lot more energy, you can pull off the electron and you end up with this mixture of positively charged ions, the atoms that have lost an electron, the electron, which is negatively charged, and that's a plasma. What makes that state different is that because they're now this mixture of positively and negatively charged particles, there are additional forces we call electromagnetic forces that are long range. So the behavior is determined by local collisions and long range electromagnetic interactions. So you can use electromagnetic fields to control the plasma. We can send a current through a wire and create a magnetic field. In principle, it's a very simple thing to do. However, in practice, it can get very complicated depending on the type of environment and the type of plasma that you're dealing with. In my lab, where I look at plasmas, we use 2 different types of electrical sources to put the power in, a really big battery. And then one is what we would call an RF power supply. This is like what comes out of your wall. One way that I like to think about a plasma, particularly on the industrial side, is plasma is a processing unit that takes in some sort of product and turns it into something more useful. You also have naturally occurring plasmas. Lightning is an example of a plasma. You basically build up a charge separation in the atmosphere, and when that charge separation gets large enough, the air is no longer able to remain in that state and it gets heated very rapidly, and at that point the gas turns into an ionized gas, which is a plasma. Another example that I like is a flame, because that's a very weakly ionized plasma, and it's actually my particularly favorite kind of plasma because one, it's a plasma that everyone has played with. And my area of expertise is in what's known as dusty plasmas. And a flame is an example of a dusty plasma. The reason that you see a flame is that inside the flame there is carbon soot, nanometer sized particles, so something that's 100,000th the size of your hair. But it's heated up to the point where it emits light in the visible part of the spectrum where we can see. So a flame is a dusty plasma, and you see it because it is hot enough to give off light. So there's naturally occurring and made. To make it, you just need to put energy in to ionize the gas. The experiments that I do in my lab, these are done in tabletop experiments. So our plasma volumes are that big, right? So maybe less than a foot by a foot by a foot. But there are other environments where they can be much larger or much smaller. There are applications where you might apply plasmas to treat wounds or to treat seeds and plants. They're used in water treatment, and those plasmas can be on the order of centimeters. If you think about a fusion device, that is creating very hot plasma, and those would fill a good-sized building. If you're looking at things like the sun, right, which is a plasma, well, that's a much larger scale, right? So they can be from something of the size of your hair up to stars. That's what makes it interesting and worth looking at.
All right, Nadish is still with us after making him have his brain grow a couple of times today, right?
Yeah.
Well, what do you think we're going to do next? Make your brain grow again.
Yeah.
Is that all right?
Yes.
All right. See, because it's just like another muscle in your body, right? The more you work it out and exercise it, the better it becomes and the more it grows, right? And we all want to know a lot of stuff, right? Can we ever know everything?
No.
It's impossible, right? But we can know a lot of good stuff, right? And there's sometimes ways that you can find patterns, especially in mathematics and other areas of life also, that make things a little bit easier and easier to recognize and things like that, right? And you'll get along with a lot of these things as you get a little bit older. But I know that you said that your favorite number was 9.
Yes.
Why is 9 a favorite number of yours?
I don't know.
You just like the number 9?
Yeah.
Well, it's the biggest number before you get into 10 and go on like that, right? It's the highest single digit number, right? 9. All right. So let's see. Are you 9?
No,
Are you older?
I'm 10.
Yeah, you're older. I was like, all right. So you like 9 because it was a good year you had last year, right?
Yeah.
All right. We'll look at it that way. So head on over to the board. You and Scott have a lot of 9s, and you have a lot of different options to get answers. In between those, you can put operation add, subtract, multiply, divide. Now, you can use parentheses if you like, if you know how to use those properly. You cannot use exponents, though, because that's adding a number. You can't add any numbers. You have to use all 4 9s in order to figure one of these out. All right? So you and Scott can go ahead and work on something together, just kind of see where you go. And I'll give you about 4 minutes, 5 minutes to work on some of these. You don't have to get them all, but if you get one, that
you want
would
to
be
start
great.
with something you think might be a little bit better. Oh, you like that one. Now tell me why. My eye was drawn to that one as well. Why is your eye drawn to that specific one?
I actually don't know.
Well, let's think. Maybe must be a
I have
reason.
an
right?
idea.
Okay, what's your idea? Tell me a little bit about it.
And then just,
Man, oh man,
so that equals
it's going to be a really big number,
7
huh?
to 9 divided by 9 equals 81.
So you're going to put a divide sign here?
Oh, yeah.
Interesting.
I need you to work that out. You're
Tell me a
telling
little bit
me
about
that
this. What if we did
729 divided
exactly
by
what we
9?
were told, that we could do some parentheses, right? Maybe we can make this look a little bit better. What if we did some parentheses right here? What would you do first in that problem?
I would do the parentheses.
Yeah, so what is 9 divided by 9?
1.
It's 1, right? Okay, so then what would you do next?
9 times 9.
Which is?
81.
81. And then what would you do with the 81 and then 1?
Times.
That's it. That's a good way to do it. So I like that you picked this one. I think that our eyes were drawn to that 81 because 9 times 9 is 81. So we just had to figure out what to do with the other 2 9s, right?
Yeah, you're correct. So there's 2 different ways to do it right there.
Yeah.
Plus, it's fun because everybody does these problems, right? John found a 3rd way to do it.
Ah, there
right?
you go. Yeah.
In studio, he was like 9 times 9 is 81 minus or plus 9 minus 9.
Yeah, if you can make this number right here a 0 by doing 9 minus 9, right? And then make this a plus, 81 plus 0 is 81.
All right, there you go. So you got 81. Try another one.
Which one am I going to attack next? Which other one catches your eye? You like the big one?
Yes.
Why do you like the big one? Oh, because you did this one before. That's right. So you know this one is 729, like you told me before, and then just subtract 9. So here's what a really neat part of this puzzle, it seems to me. You can use pieces of what you've done before to kind of categorize them back in your head. Don't forget what you've done, and then maybe use it on later on. And that's exactly what you did here. You took your 729, took away 9. It's really quick. All right, we're going over to this column over here. We're going over here. Yeah, we're going over here. I want to challenge you. Which one in this column do you want to do? And we'll see if we can work together. Okay, the one in the middle. All right.
Okay.
So let's see. Just tell me what you're doing, or tell me what you're thinking in your head before you start. What do you think you might want to do?
I'll just minus.
Okay, so tell me. So what's going to happen here?
That's a 0 now.
That's it. You're done, unless you have some parentheses, right?
Yeah.
So how can you make just 2 9s
A
into
1
9? It's going to be a tough one, huh?
9.
Because 9 plus 9, 9 times 9, 9 divided by 9, that's not going to work out for well. Maybe a negative sign was not a very good thing to do, huh?
Back.
Yeah,
Back.
I'll go back and go back one more. All right.
Back. Okay, now.
So what are you going to do now instead?
I will do.
The weird thing is this takes almost a little more thought than those other ones, and you're just trying to come up with the same number at the end, right?
Yeah.
A 9.
I have a way, but it doesn't work.
Well, what would be one thing we could do to make sure maybe if we had two different terms that we multiplied them together to get 9, what would happen there?
I have an idea. Like,
Okay.
So if you just multiply these and then just like that
Okay.
would get you 9, but I don't know what to do with that.
So this is 81 divided by 9, which is 9, and you're stuck with 2 9s again, right?
Yeah.
Man, that's a tough one. So how do we get rid of one of those 9s, in other words, right?
Yes.
Because even if you had a subtraction sign here, that would be a 0.
Yeah.
Ah, man, this is getting a little bit rough. Maybe those parentheses are going to come into handy, huh? If we could do them kind of backwards or something.
Backwards.
Well, you know what? You use the 729 here on another problem. Let's see if we can skip down to the next one, and maybe with something we do here will spark your mind as to what to do above there. What do you want to do with this one that says 10? Yeah, I know. Look at that. What the heck? We're kind of in the same spot, except we just got to go one more, right?
So if he's kind of stuck, Nadish, is there one you want to work on?
Yes, this.
He wants to go back to the big one. All right, let's do the
All right.
90. Here we go. What can we do with the 90? Okay, so you're going to get big. You definitely want to get big. Okay. So this is 9 times 9. Tell me again what's in your head. 9 times 9 is?
81.
81
plus
plus 9.
equals 90.
Oh, but we have one more 9 left.
That will give you 99 if you add that up.
Yeah, that's right. So too bad the one of them doesn't say 99, right? And we can't subtract it because we get back to 81. That doesn't work either.
So Nadish, what we're going to do is, come on over here for a minute there, bro. So this is a lovely little page to work on, isn't it? All right. So what you're going to do is you're going to be able to go home. You're going to be able to look at this program later on. You're going to be able to work on these at your home sometime, all right? Because you are now an ambassador for Do the Math. Do you know what that means?
Yes, like a visitor.
A what?
It's like a visitor. It's like
It's
guest.
a visitor. You're a visitor
it's like a guest
today, but
or
you're
a visitor.
right. But you're an ambassador for our show. That means you have to tell people about our show. Are you good with that?
Yeah.
If somebody watches our show or comes on the show, what will automatically happen to them?
They'll be seen on camera.
Well, if they don't even see, if they don't come on the show, but what's one thing that will happen to a part of their body if they watch or come on the show?
Their brain.
Their brain will grow, right? It's just one of those things, you can't help it, right? I mean, your brain's going to grow because you're going to learn something new, right? You like Rubik's Cubes?
Yes, I can solve one.
You can solve one. Excellent. I know how to mix one up. You can solve it?
Yeah.
All right, so we'll do that a little bit later on, all right? Did you learn something today?
Yes.
Good. Did you have fun today?
Yes.
That's the most important thing right there. Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, California Resources Corporation, Edison International, Center for Neural Skills, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, Tuolumne County Superintendent of Schools, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education.